Today, we are going to discuss about my study. It is entitled Non-Newtonian Fluids and its comparison to Newtonian fluids. First of all, what is a non-Newtonian fluid? A non-Newtonian fluid is a fluid, liquid or gas, that does not strictly follow Isaac Newton's law of viscosity. According to Andrew Zimmerman Jones, the viscosity of non-Newtonian fluids is not constant and varies depending on the force applied. On the contrary, Newtonian fluids that follow the law of viscosity have a proportional increase or decrease with the amount of force applied. The most common example is water. Thus, the researchers aim to determine the observable differences between Newtonian and non-Newtonian fluids by answering the following questions. What kind of non-Newtonian fluid will be made? What is the state of the matter of the non-Newtonian fluid? And determine what kind of mixture the non-Newtonian fluid is. We are going to need the following materials for this project: cornstarch, water, a container, scratch papers, spoon, and coins. Here are the steps in creating our non-Newtonian fluid. First, place the newspaper on the table and put the materials on it. Second, pour about 1/2 cup of cornstarch into the container. Next, pour about 1/4 cup of water into the container. Stir and slowly add water or cornstarch until you get the consistency of honey. If it's too powdery, add water. And if it's too soaked, add cornstarch. Testing procedure and the results. With stress tests, we use a spoon and heat the water and the mixture enough to sink the butt of the spoon into the fluid. With low, moderate, and high strength, the spoon easily submerged into the water. While in the mixture, with low, moderate, and high strength, it did not submerge. With the viscosity test, we drop a coin on the water and the mixture. On the water, the coin easily submerged, and on the mixture, it took a lot of time before it submerged. The stress test and viscosity test are the main factors in determining non-Newtonian fluids. We use the fluidity test to gather more observations about non-Newtonian fluids, since fluidity is the opposite of viscosity. We use a serving spoon and get a small amount of water in mixture and slowly tilt it to allow them to flow. The water easily flowed and the mixture took a lot of time to flow. Since stress over time is another factor to determine the type of non-Newtonian fluid the mixture is, we have included an aging test. According to Science Learn Hub, there are 4 types of non-Newtonian fluids: thixotropic, rheopectic, shear-thinning, and dilatant. Thixotropic has viscosity that decreases with stress over time, while rheopectic is its opposite, that has viscosity that increases with stress over time. Shear-thinning has viscosity that decreases with increased stress, while dilatant it has a viscosity that increases with increased stress. The mixture became almost solid and it became more viscous. We dried the mixture by taking a small amount of it and placing it in a different container. Then, we dried it using a tissue paper. This test determines the state of the matter of the mixture is, and its type by observing. Since the mixtures flow with the presence of water, the mixture is a liquid. When the mixture is dried out, the cornstarch remains, which is the solid component of the mixture. The researchers have observed that the mixture can be separated by mechanical means and it is uniform throughout. With the help of all the tests we've done, we could see the evident differences between Newtonian and non-Newtonian fluids. We also identified the type of non-Newtonian fluid using the stress, aging, and viscosity test. The fluidity test is used to gain more observations of the product, and drying the mixture was done to identify the state of the matter of the product and its type. The type of non-Newtonian fluid that was produced is a dilatant and rheopectic. Its viscosity increases with increasing stress and stress over time. The mixture contains solid and liquid materials that could be separated by drying it. The experimentation also showed that when the mixture is dried, the solid component becomes compacted. The mixture that was created was a homogeneous mixture. Its composition throughout is uniform, but it can still be separated by mechanical means. Now, the researchers would recommend the following to have a better understanding of this topic. First, the researchers should set and measure the amount of force applied and other quantitative data used to have a more specific understanding of the topic. Second, using the quantitative data gathered, prepare graphs to show the relationships of stress and viscosity of the fluids, and compare the graphs with the ones that can be found in books regarding Newton's law of viscosity. That's it. Thank you for watching.